Eric's Guitar Amplifier Repair, helping musicians to perform better. We are looking at the Vibrolux Reverb amplifier, Vibrolux Reverb amplifier. You can see that this is a road-worthy amplifier. Lower right quadrant, we have some damage here. You can see that this has been played in a lot of bars, a lot of smoke damage, so on and so forth. So this is the front view, This is one section of the close-up fuzz tone reverb speed bass. Center view, volume, treble. We have a fuzz switch here, input 1 and input 2 vibrato. We have input jack 1 and 2. This is the normal channel. We have a vibe switch, volume, treble, and bass. Again, heavily worn. Here's the rear view. Got a JBL speaker. Looks like this has been replaced. Speaker wiring and jack. Here's a close-up of the back of the amplifier control panel. So it looks like we do have a modification here. And then we have this reverb hum balance, reverb pedal, preamp output. So it looks like this is a mod, preamp out mod. And then we have our typical on and standby switch. Looking at the output tubes, 6L6 and a 6L6. And you can see this has either been stored for a long time or these are very old tubes. And then we have the various preamp and reverb tubes. So we've got 1, 2, 3, 4, 5, 6, 7. 7 tubes in this Vibrolux. And then we have a JBL speaker at 8 ohms impedance, 8 ohms. This is the view of the tube chart. This is using the AA864. This is showing the GZ34, the 6L6, 6L6, and then we have 1, 2, 3, 4, 5, 6 preamp and reverb tubes. And what did we count? We counted 1, 2, 3, 4, 5, 6. We have 7 preamp tubes. So there's a mod that's probably for the fuzz part. So we'll take a look at that when we pull the chassis. Look at how that circuit's been modified. Before we move forward, and I never apply power or voltage until I check all of the tubes. So in this next section, we're going to check the tubes. And this is just a go, no go tube test. We are looking at a go, no go tester by Eco. This is the 635 tube tester. This is the RCA tube that came out of the Vibrolux. The first tube that I removed, the whole vacuum tube envelope, glass envelope, came off. You can see here on this second vacuum tube we have a crack here in this area. So I am assuming that this is gone regardless if it passes or not. Let's test it and see what we find. And we're going to allow the filament element to see if it will light up. And I do see the filament lighting up here. That's the orange glow around this area in the center. And we can try the test. And it's passing test. Now, one may think it's a good idea to give this to the customer as a backup. However, with this crack, I think it's best to throw this tube in the trash. We will test the preamp tubes next. I will only show you the tubes that fail, so we'll move on to that segment next. We are finding that we do have a bad preamp tube. We will allow the filament to warm up, to ignite. And then we will test. And you can see it's coming up. And it's failing. Try one more time. So we will replace that preamp tube. I have a second tube in the preamp stage that tested low, and we will replace that preamp tube as well. So it's testing low, it's time for a replacement. During the preamp test process, I noticed that the filter capacitor pack is missing its cover. 450 volts at these sections. This will kill the customer. This will kill the customer if he reaches in and grabs or touches anything here. It's super dangerous. It is not the responsibility of the musician to understand electronics. It is the responsibility of the technician to protect the musician and the customer. Whoever allowed this cover to be left unattached did a pretty bad thing. I'm going to assume that the screws had stripped and maybe the cover just fell off. And again, it's not the musician's responsibility to understand that the cover needs to be on. So we'll just make that assumption. I'll order a cover, and if the screws are truly stripped, we will retap and replace that. We're going to go ahead and remove the chassis at this point, and we'll move on to that section next. You're looking at the cover. This is a replacement cover for the filter pack. This was purchased by me from Mojotone, and this is something I wanted to note. This is really a perfect, surprisingly perfect fit, well manufactured. I really appreciate things that are well manufactured. It even has a vent hole on the side here that you can't see, but there's a vent hole in this design. So I just wanted to thank Mojotone for providing a quality part. I obviously am not sponsored by anybody, and I am finding that Mojotone has been a good supplier for all of my needs. So good job, Mojotone. We are looking at the Vibrolux Reverb filter pack. Looking at the electrolytic capacitors, we can see that they are in okay condition. However, these electrolytic capacitors do have a lifespan. The lifespan can be found on the data sheet online. We are not seeing electrolytic paste or bulging at this end of the capacitor. That's good. If you see electrolytic paste or oozing or bulging, you know you're in trouble. You've extended the filter capacitor, and this can cause damage to the amplifier. We will also check the value of these carbon composition resistors. You can replace these if necessary with carbon composition resistors. However, if you are unable to find the proper wattage, you can use a flame-proof type. I like the Yagyo product from Japan. If you want a very quiet amplifier, you can use a middle film type resistor. I will be replacing these capacitors one at a time, so I will remove one capacitor, replace it with a new one, and then moving on down the line. I will be using the FNT type from Germany, or they are designed in Germany, manufactured in China. These are good capacitors. I like them a lot, and you'll see what they look like in the next segment. We are looking at the replacement of the electrolytic capacitors in the filter pack. Orientation is the negative side is towards the preamp tubes. Orientation negative, capacitor towards the preamp tubes. This is an FNT type capacitor designed in Germany and most likely manufactured in China. Looking at the left side of the circuit, you can see that this has been modified here, and it's been modified by Claveria. We have our bias circuit here, and we can see that the rectifier tube has been replaced by a diode type rectifier, diode type rectifier. Moving on to the center of the circuit, we can see a couple of things. We have a switching system here and a few more mods in this area here. There's a circuit board standoff system here. We see here these coupling capacitors are the brown type. These are fondly referred to as turd caps because of their turd-like structure. I will be replacing these. I don't like the way they sound, so I will replace these. Moving on to the circuit, we can see we have these Mallory electrolytic capacitors, and again they have a lifespan. We will be replacing these with a Sprague and Adam type. That's what I like. And we will replace all of these electrolytics all the way down to the beginning of the circuit. Looking at the preamp section of the circuit, we can see more of these ugly brown capacitors. I may replace the 0.1 microfarad capacitors just because I don't like these capacitors. Now, if they're not leaking DC voltage, maybe I'll leave them in. We'll see what I choose to do, but of course we will replace all of the electrolytic capacitors. This will improve the sound greatly. Looking at the bias circuit, we have replaced the capacitor. Please note the orientation. We have the positive side going to ground. This is a negative bias circuit. Capacitor is a 100 microfarad at 100 volts. Looking here, we have a modified circuit. Instead of a tube rectifier, this has been replaced by a diode rectifier. I do like the way that this particular technician created this mini circuit here. Well done, well done. We'll clean that up a little bit, but this is a nice way of modifying the rectifier portion of this circuit. We have a toggle switch in the on-off position that is broken. You can see that it's wiggling around. It looks like it may have been replaced at one point. You can see the diameter of the standby switch compared to the on and off switch, and the diameter is much larger here than here. So this was replaced with a low-grade switch. We have a switch here that is a little more robust. I'm not sure if this is the actual, well, it looks like it is the direct replacement, so we'll take care of that right now. Here we're taking note of the on and off switch wiggling around in its chassis, and we will take note of the wiring orientation. Here is a shot of the replacement switch, power supply switch, power switch. This is what we have done so far to the circuit board. We have these metal film type coupling capacitors. These are the Dijon by Mojo Tone, 0.1 microfarad, 0.1 microfarad, and so on and so forth. We have the first preamp section of the electrolytic capacitors replaced. Side note, this is 25 microfarad at 250 volts. And this is not necessary. It only needs 25 volts. This is what I had in stock. This is super overkill, super over-engineered capacitor replacement, but I won't charge the customer anything more than what I would charge for the 25 volt electrolytics. We're waiting on an order. The order consists of replacement of all of these electrolytics by Mallory, 2 output 6L6 tubes, 2 12AX preamp tubes, and the rest of the filter pack, which we will take a look at once the parts come in the next segment. This is the power switch that was removed, and you can see that we have a gap here, and this is what was making it loose, I believe. So we're just going to line everything up here, and note that there is a screw here, a set screw, and we are going to tighten that set screw. And for some reason we are missing the other set screw here, but I did find it. It was floating around in the chassis. This is what it looks like. This is the set screw floating around in the chassis. Very dangerous. This will cause havoc if it touches any of the live part of the circuit, if it's bouncing around. I have no idea how this happened or why it would happen. This is probably just bad manufacturing on the switch part. There was probably no Loctite added purposely. So this switch, I will assume, is now functioning properly. We will return this to the customer. Yeah, and everything seems to be working fine. I will test continuity and then return to the customer, but this is something you can look out for if you see something similar, if you have this same type of switch. I do want to note that this is a highly modified Vibrolux. We have this installment of some type of what I assume is a switching circuit. This is, just by looking at the outside, very, very well done. The technician who did this did a fabulous job, I think. On the other side, we have 2 connectors. I'm assuming one is for reverb and one is for a foot switchable distortion type circuit within the other side of this chassis. So very interesting. Well done. We have replaced the electrolytic capacitors here in the circuit and here as well. This is a highly modified circuit by Claveria. Very well done. the technician or engineer who modified this amplifier did a very, very good job. We have replaced the 6L6 tubes with the JJ type 6L6 tube. I like this tube a lot. We've also replaced two preamp tubes. Two preamp tubes that were replaced were here and here. Again, this is a very highly modified amplifier. Now it's time to bring the voltage up on the amplifier. We will do this very slowly using a variac. I will monitor the voltage by placing a negative probe from my digital voltmeter to the negative or ground connector that is attached to this particular potentiometer in this particular circuit design. We have 3 lugs, 1, 2, and 3. I will place my positive digital voltmeter probe on the center lug, and this will allow me to monitor the negative bias voltage. This is a great way to detect if there are any problems in the amplifier as you're bringing up the voltage slowly. We are bringing up the voltage slowly, very slowly, and letting it rest in between certain voltages so that the electrolytic capacitors can form, so they can form properly. We're looking for a negative bias voltage of around negative 42 volts. Because this amplifier has been highly modified, that includes a sophisticated diode circuit, I suspect that the negative bias voltage will go beyond negative 42 volts. This is fine. We are looking for the 6L6 to be approximately between negative 40 volts to negative 48 volts. This is the acceptable low and high limit. Let me go ahead and set up my probes now for demonstration purposes. And next we will bring the voltage up slowly. So we are about to turn on the amplifier for the first time using a variac bringing up the voltages. I do want to note that I have a speaker plugged in to the amplifier. I am not using a dummy load. I want to hear if anything is happening to the amplifier as it becomes live. We will start out with having the amplifier in the standby mode, so the switch is on, but we are in the standby mode. We will bring the voltages up slowly, resting at certain points, letting the electrolytic capacitors form. Here's an example. Let's begin the process of bringing voltages up on the amplifier for the first time. We will set the digital voltmeter to DC volts. We have our switch on the amplifier, but we have the standby in the standby mode. And we will bring up the voltages slowly here. And you can see the negative bias voltage coming up. And I'll let it sit at negative 10 volts for 5 or 10 minutes. Then I will continue to bring it up to about 40 volts on my variac. And we're seeing negative 15 volts. This looks good. We're showing signs already that this is working properly. And I'll let that sit there for another 5 or 10 minutes. Again, I'll bring up the voltage from around 40 to 60. And you'll see that the indicator lamp will come on right about this point. It'll be dim, but it'll come alive. And again, I'll let that sit there for 5 or 10 minutes. And then I'll bring the voltages all the way up to about 110. Bringing it up very slowly. We're at 101 at this point, and it's negative 38. That looks good. And we'll continue that. I'll bring up the variac to about 112 or 113. Now this is far below the voltages that you might be getting out of your wall. You're getting normally you're getting about 117 volts out of the wall. And that's where I do the final bias set. So this is in the standby mode, so I will switch off the variac, place the amplifier out of standby, and again repeat the process. Repeat the process. It's pretty simple. So you'll do that, you'll set your bias voltage to negative 42 in this case. If it exceeds that, if it's a highly modified amplifier like this, it'll most likely exceed. This one did. It did exceed negative 42 volts. It was negative 44. I think that's fine. We're going to verify that using a oscilloscope and injecting a 1 kilohertz sine wave at 2 volts. And then I'll just verify that that's an acceptable bias voltage, and you'll see that in the crossover distortion. And so we have a 1 kilohertz sine wave going in at 1 volt, and we're bringing up the volume, and we can see the crossover distortion here isn't too bad at negative 44 volts bias. I'm going to accept this. This should sound really nice. Eric's Guitar Amplifier Repair, helping musicians to perform better.